name is Emma. I live in the computer science department at the University of West Georgia. I work with students and faculty to learn and to teach. I like to be with the students the most. We always have so much fun working on projects and researching. I would like to invite you to come to join us here at the university. We get all the best toys and we have all the best faculty and staff. I hope to see you soon. And remember, the best go west.
Right now we're working with motion scripting. We're trying to figure out how to get him to walk faster, to jump, to run. Anything that we can deal with in motion-wise, we're trying to dabble in right now. Really what we want to be able to do is give him an internal representation of himself. We want him to know that he's standing or that he's sitting or getting ready to take a step. And we want him to be able to predict what happens when he takes his next step. If he's going to fall, if he does fall, how can he get back up? Really, it's trying to bridge that human knowledge into robot knowledge. One of the big ones that comes to mind when I think about DARwin, or look at DARwin, is EOD, Explosives Ordnance Disposal, which is the diffusal of bombs, which right now is a really big concern. With DARwin, a humanoid robot, he has the ability to go in places that we can't get to. He's small and maneuverable, he has a lot of torque, and he can pick things up, can carry a small payload. Now through teleoperation, which means when he moves, or when I move, he moves. So I basically can control DARwin using body motions or certain commands that can go to him wirelessly. I can stick him in harm's way, I can put him where I don't want to be. I can get him to go to the location of the said bomb or explosive device, and he can survey the item. He can actually manipulate it using hands, and we can include special devices connected to him to go in and cut wires or check to see how everything's going on. And then, if need be, he can actually pick up the device or carry it somewhere away from us. He can do everything that we need to without, getting within a mile of the object. This really is a super sophisticated version of the EOD bomb squad's little bombs that they put in harm's way. And having this open platform, we can program DARwin to do a multitude of tasks and experiment with what works, what doesn't work, how we get him to move. If we can get him to move, what different items can we use, can we give him that he'll understand. So if I were to give DARwin a hammer, obviously he will have no idea how to use it. But if I teach him, this is how a wall needs to be constructed, I can give him all of the specifications for building a house, all this, the state laws and federal laws. He should be able to go and construct a wall and then use the information that he has stored within him to check quality assurances, to make sure that the studs are the right number of inches apart. He can also check to make sure that the wiring is in the right location. By offsetting the need for humans and replacing them with robotics like this, I mean, the effectiveness is just going to skyrocket. Productivity will go up. All this stuff can be done all the time, 24 hours a day. And the fact that we have this means that we can start paving the way for robots that act like this and actually work like this.
Hello ladies and gentlemen, my name is DARwin. I'm a humanoid robot designed for research. I would like to thank Brandon and Kenitra for introducing me. I live in the computer science department here, and it is pretty scary for me. They keep giving me new voices and taking me apart. They can never remember where all the screws go. I'm afraid one day they will lose something.